Hey guys, I am Deep Patel, a BTech CSE student at Bennett University. Today, we have to discuss a very hot topic around the world, that is augmented reality. Even if you have not heard about it, don't worry. I am here to help you. So tighten up your seatbelts and let's go on a ride to augmented reality. Wondering what does that mean? Let's break it down into simple language and let's begin. As taught in a school, everything in science has its own definition, and here is a definition of augmented reality, aka AR. An enhanced version of reality where live, direct, or indirect views of physical real world environments are augmented with superimposed computer generated images over a user's view of the real world, thus enhancing one's current perception of reality. The origin of the word augmented is augment, which means to add or enhance something. In the case of augmented reality, also called AR, graphics, sounds, and touch feedback are added into a natural world to create an enhanced user experience. In layman's language, it is a mixture of what we see and what computer adds to our vision. Let's brief AR into its types. AR is listed into four types: marker-based augmented reality, markerless augmented reality, projection-based augmented reality, and superimposition-based augmented reality. Marker-based augmented reality. Marker-based augmented reality uses a camera and some type of visual maker, such as QR code, to produce a result only when the marker is sensed by a reader. Marker-based application uses a camera on the device to distinguish a marker from any other real-world object. Markerless augmented reality. A strong force behind markerless augmented reality technology is a wide availability of smartphones and location detection features they provide. It is most commonly used for mapping directions, finding nearby businesses, and other location-centric mobile applications. Projection-based augmented reality. Interesting application of projection-based augmented reality utilizes latest plasma technology to project a three-dimensional hologram into midair. Projection-based augmented reality works by projecting artificial light onto real-world surfaces, allowing for human interaction and then sensing the human interaction. Superimposition-based augmented reality. Superimposition-based augmented reality either partially or fully replaces the original view of an object with a newly augmented view of the same object. By downloading an app and scanning selected images in their printed or digital catalog, users can place virtual IKEA furniture in their own home with the help of augmented reality. The main objective of AR is to bring computer generated objects into the real world, which only the user can see. Augmented realities can be displayed on a wide variety of displays, from screens and monitors to handheld devices or glasses. Google Glass and other head-up displays put augmented reality directly onto your face, usually in the form of glasses. Here is an example of augmented reality in the form of Google's own project, Project Tango.
My name is Johnny Lee, and I work in the Advanced Technology and Projects Group at Google. Our small team here, based in California, has been working with universities, research labs, and industrial partners to harvest the last 10 years of research in robotics and computer vision to concentrate that technology into a very unique mobile phone. We are physical beings that live in a 3D world, yet mobile devices today assume that the physical world ends at the boundaries of the screen. Our goal is to give mobile devices a human-scale understanding of space and motion.
This is going to allow people to interact with their environment in just a fundamentally different way. We can prototype in a couple hours something that would take us months or even years before because we didn't have this technology readily available.
What happens if you have all of these pieces in a phone? How does that change what a phone is?
We have created a prototype phone containing highly customized hardware and software designed to allow the phone to track its motion in full 3D in real time as you hold it. These sensors make over 250,000 3D measurements every single second, updating the position and rotation of the phone, fusing this information into a single 3D model of the environment.
We have a problem called navigation indoors, and it's a solution to that problem.
It tracks your position as you go around the world, and it also makes a map of that.
Imagine that you scan a small section of your living room and then are able to generate a little game world in it. I don't know of any other controller or gaming device that can do that at the moment.
Putting all this together, they pulled in experts from all around the world and got them all working on the same project.
Those are very high caliber people. Why? It's very simple. I think actually people believe in the vision.
Localization and mapping is there on your phone and you just use it. It's this ability to follow in other people's footsteps.
And we can also benefit from what we do for the project back for the open source community.
Use it for visually impaired, give them auditory cues on where they're going.
You know, being able to map your home. Oh, check out, let me see how this furniture looks in my room.
Virtual windows to sort of different worlds. I mean, the possibilities are really endless.
Over the next few months, we will be distributing dev kits to software developers to develop applications and algorithms on top of this platform. We are just in the beginning, and we know there is a lot more work to do, but we are excited about where it is going to go. The future is awesome, and we believe we can build it faster together.
As you have seen the Project Tango and its vision, let's say its application, as without application all the theory is in vain. Asus, a Taiwanese manufacturer that manufactures products in different domains like mobile industry, laptop industry, etc., has released a mobile phone named as Asus Zenfone Air, which uses Google's Tango and Daydream project.
We grow up exploring and learning about the world around us. With ASUS Zenfone AR, augmented and virtual realities will elevate our world to a whole new dimension. Zenfone AR uses the TriCam system and computer vision software to provide Tango's motion tracking, depth perception, and area learning to bring augmented reality to users. With this sophisticated integration, Zenfone AR delivers engaging augmented reality experiences for you to explore and enjoy. The 23-megapixel camera provides a crystal clear backdrop for the augmented reality. The motion tracking camera lets Zenfone AR track its location as it moves through space, and the depth sensing camera detects the distance between objects.
Unfortunately, Google discontinued Project Tango and within few months came up with Google AR Code API, which is now available for a lot of devices out there. For example, OnePlus phones, Nokia Android devices, Google Pixel lineup have AR Code built in, which gives them an edge to use AR-based application. As we have seen the Asus Zenfone Air, you have seen the components that it required for AR-based applications. Here are the key components to AR devices. First, sensors and cameras. Second, projection. Third, processing. Fourth, reflection. Many people have confusion between two things. They are not able to differ augmented reality and virtual reality. Let me do that for you. Virtual reality uses our vision. It's 99% of our vision and only 1% use of our hands and legs. To enter into virtual reality, we have VR headsets. Companies like Google with its own product Google Daydream, Microsoft with its HoloLens, and tech giant company Oculus in partnership with Xiaomi have immensely progressed in the field of virtual reality. Virtual reality and augmented reality accomplish two very different things in two very different ways. Despite the similar designs of the devices themselves, VR replaces reality, taking you somewhere else. AR adds to reality, projecting information on top of what you have already seen. They are both powerful technologies that have yet to make their mark with consumers, but show a lot of promise. They can completely change how we use computers in the future, but whether one or both will succeed is anyone's guess right now. The biggest and famous example for AR related game is Pokemon Go. Alright guys, that was my time with you.